Did you know that the first ever Mars rover was built in the Soviet Union and landed on the Red Planet in the year 1971? This was the humble beginning to a long line of Mars exploration vehicles that would continue to evolve over the decades and eventually progress from the land to the air. The 1971 rover was part of a Soviet mission called Mars 3 that became the first man-made object to achieve a soft touchdown on the planet's surface. The mini rover carried by Mars 3 was named Prop M. It was essentially a small metal box, just 21 centimeters long and 16 centimeters wide, weighing in at 4.5 kilograms. The Prop M didn't have wheels. It used a pair of wide, flat skis mounted on arms that would allow it to step forward slowly. The rover was tethered to the main lander with a 15-meter power cable, and its purpose was to use a small onboard probe that would measure the density of Martian soil. The Mars 3 landing was a major accomplishment for the time, although it was short-lived. After just 14 seconds of transmission, the signal from Mars went dead. The only data that was received was this scrambled black and white image, and the Prop M rover was never deployed. Our first successful close-up examination of Mars dates back to the mid-1970s and NASA's Viking landers. These were essentially scientific instrument clusters that made an epic journey all the way down to the surface of the Red Planet and delivered first-hand information about the composition of Martian soil. NASA launched both Viking 1 and Viking 2 in the summer of 1976 to take advantage of a close proximity window between Earth and Mars that only opens once every 26 months. And on their arrival, the two probes returned the first ever detailed photographs of the Martian surface. And this is what they saw. By placing two landers in different areas of the planet, NASA was getting the most diverse sample range possible, but these were still just 2 scoops of sand in a planet-sized desert. The odds of finding an ancient fossilized Martian bacteria using this method were not in our favor. So Mars landings were put on hold for 2 decades as NASA worked on developing their solution for exploring the great unknown. In December 1996, NASA was ready to send a new payload to Mars, the Pathfinder. Again, this was a scientific instrument station that unfurled itself on the Martian surface to reveal a collection of scopes, cameras, and meters. But Pathfinder also brought along with it a small prototype vehicle, this little guy, Sojourner. Anyone who was around in the late 90s remembers the original Mars rover. This thing was a pop culture icon. It was incredible. We were driving around a remote-controlled car on another planet. The future had arrived. Sojourner was a technology demonstration. No one really knew what was going to happen when you started trying to drive around a tiny car millions of miles away on the surface of an alien planet, but there was only one way to find out. The first Mars rover was about the size and weight of a microwave oven. It had 6 wheels, each with their own independent electric motor and an experimental new suspension system that was called the rocker bogie. It looks like this. It's essentially 2 linked arms that attach the wheels to the body. There's a long arm called the rocker in the front and a short arm called the bogie in the back. This allows each wheel to pivot independently so that all 6 remain in constant contact with the surface. Thanks to Viking, we know that Mars is not smooth and sandy like a desert. It's littered with small chunks of jagged rock, and the last thing that NASA wanted was for their new rover to travel millions of miles through space just to get stuck before it could do any science. With this new high-tech suspension system, the rover could safely overcome obstacles up to 1/3 of its own size. And in this iconic photo taken by the lander's camera, we can see the rover conducting an up-close examination of a large boulder. Because this rover was in such an early phase of development, it didn't carry a whole lot of scientific equipment. That was still mostly handled by the lander platform, but Sojourner was equipped with a front-facing instrument called an alpha proton X-ray spectrometer, and that allowed it to determine the chemical composition of any rock that it could drive up to. The rover was even equipped with an early form of autonomous driving, not so different from what we see in modern vehicles. It used a combination of camera vision and lasers to identify obstacles and maneuver around the Martian landscape. Because the NASA team on Earth could only communicate with the rover once per day, they would essentially have to set a waypoint location that the rover would drive towards and then tune in the next day to see where it ended up. So it was a pretty slow process of exploration, with the rover covering about 100 meters of driving in its 3 months of operation. I know that doesn't sound like much, but it was significantly more performance than NASA scientists had hoped for, and it gave the space agency enough confidence to double down on the Mars rover in a very big way. When you look at space exploration, progress usually comes from removing failure points, fewer workarounds, better engineering, systems that are precise enough to just work. Now, if you look at most consumer products, their goals are different. It's not about precision, it's about appealing to the broadest set of customers. But what that means is you often get poor system design. So while we have upgraded almost everything else in our lives with better tools, shaving somehow stayed stuck in a disposable plastic system that never evolved. That is what Henson Shaving set out to fix. Henson is a Canadian company that makes razors with extremely tight manufacturing tolerances. The blade is exposed just 0.0013 inches, which reduces blade flex and chatter, the things that actually cause irritation. You do not need to press or compensate, the design does the work for you. They tested this clinically too. Henson reduced redness and irritation by up to 4 times compared to standard cartridge razors. Once you feel that difference, it's hard to go back. And what stood out to me was not just how much better it feels to use, but how good it looks. Clean lines, solid construction, and a design that feels intentional. It is the kind of object you actually like keeping on your counter. If shaving discomfort has always felt normal to you, this is worth a look. Sometimes progress is not about doing more, it's about choosing a better system. So click the link in the description and use code THESPACERACE to get 100 blades for free. That's over 2 years worth of shaves. If one little Mars rover was able to captivate the world and write new chapters in planetary science, then just imagine what 2 big Mars rovers might accomplish. This was NASA's plan with the Mars exploration rovers, Spirit and Opportunity. Both machines were launched on separate Delta II rockets in the summer of 2003, taking full advantage of that fleeting Mars transfer window. This time, instead of a lander that deployed a separate rover, the lander was the rover. After shedding its protective landing shell, each exploration rover unfurled solar panels, scientific instruments, and wheels, then set off into the Martian desert. It's very difficult to get a sense for how big these machines actually are because we have no known reference points on Mars. So where the Sojourner rover was about the size of a microwave, Spirit and Opportunity were closer to the size of golf carts. NASA had essentially just scaled up the 6-wheel drive rocker bogie system to create these next-generation rovers. The extra size and capability allowed the full collection of scientific instruments from the lander to now be fully mobile for the first time. In the top of a 1.5-meter tall mast, each rover had 9 digital cameras. They were used for both navigation and to create 3-dimensional panoramic images of the Martian landscape. The exploration rover also had its main spectrometer placed on the end of a robotic arm that extended out from the front for closer examination of rocks and soil. With all of the upgrades over their predecessor, the twin rovers were able to accomplish orders of magnitude more exploration and data collection than any previous Mars mission. The Spirit rover had a lifespan of 6 years and drove 4.8 miles, which was impressive, but Opportunity went even further, exceeding all expectations to last over 14 years and cover 28 miles of the alien landscape before finally succumbing to a giant Martian dust storm that smothered the rover's solar panels and drained its battery dry. The successor of the Twin Rover mission allowed NASA to learn a lot about navigating the Red Planet, and within just a few years, they had a new evolution of the vehicle design ready for liftoff. This is the next generation of Mars rover. You are looking at a selfie taken by a robot on the surface of the planet Mars. In the year 2012, this rover, named Curiosity, became the first of a new breed of vehicle to roam the Martian surface. Again, we have to establish a sense of scale here because this machine is a lot bigger than most people realize. So here is our microwave-sized Sojourner, and here is our golf cart-sized Opportunity, and now we bring in Curiosity. This is around the size of a crossover SUV. It's really big. You'll notice we have the same 6-wheel drive powertrain and a much bigger and beefier version of the same rocker bogie suspension system. At this scale, you can really see how the wheels are linked to the main body of the rover. You'll also notice that unlike its predecessors, Curiosity does not have solar panels. Instead, the rover is powered by a radioisotope thermoelectric generator. Heat generated by the radioactive decay of a plutonium isotope is converted into electricity by thermocouples, and any excess heat not turned into electricity is used to keep the systems warm during the Martian night. With 11 pounds of plutonium-238 on board, Curiosity's generator has a minimum lifespan of 14 years, and the rover is still going strong to this day. In 2021, Curiosity was joined on Mars by its own twin rover, Perseverance. Part of the Mars 2020 mission, Perseverance is mostly the same car-sized platform as its older sibling, just with an upgraded collection of scientific instruments and recording tools. It carries 7 primary payload instruments, 19 cameras, and 2 microphones. It was the first time that audio recording equipment had been sent to Mars, and that's how we know that the wind on the Red Planet sounds like this. We can also hear the sound of the rover itself as the hollow metal wheels clang over the Martian rocks, the gentle whirring of the electric motors, and the squeaking of the suspension system. And thanks to a very special payload delivered by Perseverance, we have this. You are hearing the sound of a helicopter flying on Mars for the first time, and this is the view from 80 feet above the Martian surface. Just like Pathfinder back in 1996, Mars 2020 brought along one small piece of experimental technology. A helicopter drone named Ingenuity hitched a ride in the belly of the rover and was deployed on April 3rd, 2021. We've seen NASA make some pretty amazing progress with their rover vehicles over the 25-year period that we just covered, but there is still only so much that can be accomplished on wheels. There are no roads on Mars. This is rugged and uneven terrain, so inevitably you will reach a hill that is too steep to climb. If we want to take interplanetary exploration to the next level, we have to learn how to fly. In many ways, Ingenuity was NASA's biggest risk yet when it came to tech demonstrations on Mars, because we knew without any doubt that wheels would work on Mars just as well as they do on Earth, but propellers are a whole other story. This is a DJI Phantom drone. You've probably seen one before, maybe even own one yourself. It's not so different from NASA's Mars drone. Side by side, they are both about the same size. The DJI is a bit smaller overall and about 1 pound lighter than Ingenuity, and using 4 tiny propellers, the Phantom can rise thousands of feet into the air, while Ingenuity uses 2 relatively giant propellers with a 4-foot wingspan, and with this, it achieves a maximum height of around 80 feet. Ingenuity needs much larger flight hardware to accomplish much less performance because it is flying in an environment with less than 1% the atmospheric density of the Earth at sea level. To find an equivalent air density on Earth, you would need to go to an altitude of 87,000 feet. The highest anyone has ever flown a helicopter is just over 40,000 feet. In order to test the helicopter's flight system on Earth, NASA had to use a vacuum chamber that simulated the low-density atmosphere of Mars. They also had to use a cable system that would pull up on the helicopter at just the right tension to simulate the reduced gravity effect as well. They even had fans blowing air across the chamber to try and simulate wind on Mars. Due to all of these factors, the propeller system on Ingenuity is very unique. Each blade is specially shaped for maximum lift. They are constructed from an ultra-lightweight foam with a carbon fiber reinforced shell. To achieve liftoff on Mars, the blades need to spin at double the RPM that would be required on Earth, but that's not why the drone has double propellers. You see, the 2 propellers are counter-rotating to keep the drone stable in flight. A traditional helicopter uses a tail rotor to do the same job, and a quadcopter drone uses 2 sets of counter-rotating propellers on opposing corners. Because of the small size and high energy requirements, Ingenuity is limited to a maximum of 90 seconds flying time before it has to stop and recharge. The internal systems have a lot in common with a modern smartphone. It uses 2 Sony cameras, half a dozen Sony lithium-ion battery cells, a cell phone-grade inertial measurement unit, a Garmin altimeter, and the batteries are all charged by a solar panel mounted to the top of the drone. With all of the technology built into Ingenuity, there was still doubt that a helicopter would actually be able to perform on Mars. Even within NASA, there was opposition to this project, and some top officials thought it was a waste of resources to ship the drone along with Perseverance. The initial technical demonstration had only planned for 5 flights on Mars at best. But, just like the Sojourner rover before it, the first Mars helicopter has far exceeded expectations for its performance and longevity. In 3 years of operation, Ingenuity completed 72 flights, accumulating 129 minutes of time spent in the air. This initial success has already begun to fuel new concept ideas at NASA. Just like the evolution of rovers from Sojourner to Spirit and Opportunity, the same is now happening with flying machines. The Mars Science Helicopter is a 6-propeller drone with a mass of around 30 kilograms. The much larger hexacopter would be able to fly up to 10 kilometers in one mission and carry up to 5 kilograms of scientific payloads along for the flight. If we remember, the Spirit rover covered just under 8 kilometers in its entire 6-year lifespan, so to fly further in one day with the Mars Science Helicopter would be a gigantic leap forward in our exploration of the Red Planet. We know that NASA is also envisioning a pair of Ingenuity-like helicopters for their Mars sample return mission in 2030. As the Perseverance rover explored the Jezero crater, it has been collecting samples from underneath the surface regolith and leaving them behind in sealed tubes. The idea is that eventually, NASA will follow up to collect the sample tubes and return them to the Earth for study. The original idea was to use a fetch rover that would essentially retrace the Perseverance journey and collect the tubes, but with the unexpected success of their demonstration helicopter, NASA is thinking that flying machines will be much faster and more efficient for retrieving the samples. And this doesn't end on Mars either. Dragonfly is a quadcopter drone that will fly on Saturn's moon Titan. This is a surreal world where the frozen surface is covered by flowing rivers and seas of liquid methane, so alien that it is almost incomprehensible, but the thick nitrogen atmosphere of Titan makes it an ideal location to fly a drone. In many ways, we are lucky that Mars offers such a challenging environment to practice flying so relatively close to home, because if we can master the art of flight on Mars, then the possibilities for exploration in our solar system will be nearly endless.